Alright, so what do you got? I asked you the question to explain to me what occurs when electrons go from the excited state to the ground state.
They go from an energetic state and then they go back to where they naturally should be. After they use energy. I don't know. That's just how I've dumbed down what I put.
They change energy.
You alright?
No, it's bland. No, look like I'm a lot. It hot. I don't like it, okay? It hot, okay? You want to go ahead and do it? I hope you go ahead and call and you see that is blood. I'm injured. I'm a patient. You should stop being so mean.
Patient? I'm not a doctor.
Okay? You're supposed to be a good Christian man now. I'm
Jesus
supposed to care about the people.
I do care. I asked if you were okay.
And then you start mocking me. Hold on your tongue like that.
Because you gave me sass.
You're not mean that. I'm trying to sense
Your
my
berry's
injury.
bleeding.
It hurts, okay? And there's blood in my cap. I can't even put that on.
You can't. Your blood. It's gonna hurt.
I don't want to drink my blood. I'm not into that.
You don't drink your blood. You just put the cap back on. It's not like you're gonna open it and just squirt all in your cap, bruh.
She put her tongue in the middle and then closed it.
It was an accident. It got stuck.
That is stored.
Okay, anyway, so.
So bad. Oh.
It takes forever to brush. And it sucks.
Alright, so, hey, first off, reminder to you about tomorrow before I give you, like, an answer and tell you how incredibly awful your answer to my entry slip today was.
At least I gave you an answer.
Yeah, I
It was
appreciate
terrible,
that.
but I gave you one.
What is the answer?
I will tell you this, you actually saved everybody because whenever I gave them time to talk in groups, you were the only person that was helping somebody.
Let's try.
Yeah, that's why I said you saved them, because I was getting ready to, like, let them have it and say, focus on the stinking question. Gotta get everybody back.
I am injured. It hurts so bad.
Don't stick your tongue in it and close it.
I didn't mean to, Mr. Hall. From accident. Just trying to.
Alright, so
enjoy the drink.
what happens when electrons go from excited state to ground state? So the first thing is you gotta we get from ground state to excited state, what's it mean?
Energy.
Gotta have energy. So we gotta have energy. Once it has energy, it'll go from the ground state to an excited state. But does it stay there?
No, it gets nowhere.
No. It will leave the excited state, return to the ground state, but what happens?
It releases photons, and then it has to release some energy to go down.
Bingo. Energy cannot be created nor destroyed. It's only allowed to be transferred from one form into another. So since this is what's going to happen, we can't just do away with the energy. The lower energy level requires a lower amount of energy for it to be able to get into that energy level. So it has to lower the energy level. Well, how is it going to do that? It has to give energy off. And what is the greatest form of energy it could give? Thank you. What's a photon?
Oh, a quantum of energy with no mass.
Quanta of energy with no mass. Hey, I got a question for you. What is a photon?
Quantum energy with mass.
Thank you very much. Hey, yo, everybody. What is a photon?
A quantum of energy with no mass.
We got to get everybody awake this morning. What is a photon?
A quantum of energy with no mass.
We lost everybody on that. Like, everybody just dropped off. Like, no, I ain't.
They probably can start.
What is a photon?
Quanta of energy with no mass.
What is a photon?
At least just try to say it.
What is a photon?
I can't say that.
Why? Do you not
I can't
speak
say that.
English? You're
I
speaking
can't
here
say
right
that.
now.
I can't say that word.
Quanta.
I can't say it.
Say quan.
One,
Say ta. Now put it together, one time.
I want for you to say something so bad. I learned for you to be like quampa or something like that. It would be so funny.
So it'll give off these photons, which then gives us the,
Is it hit the?
At least I didn't call full jump today.
yeah, I appreciate that.
You're welcome.
That's what I wanted.
So it's going to give off these photons, gives off energy. Once it gives off the energy, then what we have is we have electromagnetic radiation being given off. So tomorrow,
We'll see light.
I really thought about jumping back and doing a lab that I like to do, but I was like, no, we'll jump and do the lab that they want to do. Which, speaking of that, I need a safety contract from you, and you need to take a safety test before you can do labs.
So,
You
today?
got your safety contract?
Safety test.
No, fine.
Oh my God, the safety test.
Make a
is the
reminder on
hardest
your
thing
phone to
to
bring
read
it.
a lot.
Because if they don't have that, you can't do it. If you can't, don't take the safety test, you can't do it.
Maybe you should.
Especially tomorrow.
You should let her take the safety test. Now, show her all the stuff, and like, we'll just sit here and be quiet.
How do you use the default?
Let her focus. I'm just trying to help her out. It's the
That's
lab
the most difficult
before
thing I'll ever do.
Yeah.
Not tell them how to
Yeah,
get through.
we have to move forward. We've made good pace, but we've had a lot of interruptions, so it's kind of killed us. Like big time. All right, Sue. Yes.
If I don't come tomorrow, what would I have to do to make up that lab? Like, would I have to write an essay or something?
Does it look like I'm gonna grade an essay to you?
I don't know. I mean, surely wouldn't be one to go
Don't
to
you
my
want me to
grade
grade your essay?
No.
No.
I just wouldn't have to make it up.
I was gonna say, he came out, he don't even appears on his sentences half the time. Think about grade your essay.
That's the point.
Brother, this is not starting off.
Mr. Hall, I apologize for all of their meanness.
Leave me a sucker.
Have you even taken your test yet in here? Have you taken another test? Yeah, then don't be apologizing. Don't be acting like all good.
I'm not
student.
being mean though. Or
We're talking
talking
stuff about your
experience
junior
or
class. Your
honest.
junior class is just so sassy with each
It
other.
hasn't changed since
My
freshman
fifth
year.
period's exactly the same, and it's just like boom, 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 boom. It is like brutal. The senior class is kind of like, yeah.
Because they
That's
don't
because
care.
they don't want to deal with this junk no more. They're like, man,
We haven't heard since freshman year, to be fair.
So we're going to look at different uses that we can actually have for using ground excited
I
states.
just want to know how much energy it has to take from one to the other. You just say that it has energy, but how much?
There's certain energy levels for each one, but it differs. We can't just look at certain ones. We that like literally we take the whole year and look at it.
Because science,
We're
I
not
mean-
taking the whole year to look at this.
because science is stupid.
So there are uses of effects of going from ground excited states. So like the big one is you have to understand what comes from the electron moving from excited to ground states. What we're going to see whenever this takes place and this happens is you will see photons given off. So photons remembering what photons are, so those are
Do you want to answer or you want to tell us?
particles of electromagnetic radiation which have no mass and a quanta of energy. Which brings me to a question.
Yeah.
How can we determine what is on a planet we have never visited?
I don't know.
It's a really good question.
A different way to look at stars.
Nah, bro, we can't do it no way. Probably do it like this.
Oh god.
Give me some time to think on that.
I don't like how you're giving out all them boxes.
What?
Because it's scary. It's getting something out of a cabinet kind of day.
Don't worry. It's just Schrodinger's box. We're gonna find out if it's alive or dead.
Oh, okay. That's fine.
If you don't get that reference, you will eventually. So how can we do this? Anybody got any idea?
There might be different elements.
Telescopes.
Oh. Fair enough.
How about show and tell?
Well, you're gonna show us and probably tell us, so let's see it.
This is something very popular. You've seen this before. You've actually heard of this. It's the same premise. What these are,
what happened to
you guys
the
haven't
dropper?
seen these before, but these are cathode tubes. What's in it
Yeah.
is
So
one element.
what element?
I won't tell you what this one is because this actually gets its name from this.
What's that thing?
For us to do this, we gotta turn the lights off.
The light switch is over there.
I knew that one off too, dude.
My bad.
You're such a weird.
Press the red button.
What?
I'm trying to watch.
You can't listen and watch at the same time?
I thought you walked into the desk.
You've seen this before.
You sure?
Yeah, you have.
You sure?
Is that
Oh, it's a lightsaber.
That is not a lightsaber.
I've seen
Lightsabers
this
are never gonna be able to exist.
I was gonna ask you.
And for those of you that wanna look at me and say, yeah, dude, they already exist. No, that's a plasma saber. That's made from plasma, not light. Hence, it can't be a lightsaber.
I thought it was a computer.
It's not. You've seen this before. It's very popular.
Is it a
I'm
light?
telling you, I have not seen that.
Okay.
Las Vegas is full of them.
I've never been to
What's
Las
wrong
Vegas.
with you stand behind that light?
Why?
I just have to make a phone call.
You can get a picture.
What would
But I need you like stand by. Because it kind of looks like Darth Vader.
So,
Tyler, send me that picture.
what?
That's
Oh
you.
my gosh.
Can we take a phone call?
What is this? It's better if you do it without the flash.
Sorry, Bob, I was taking a phone call.
It's a neon light, but
It's a neon light.
does that mean it has neon in it?
These is neon lights.
Yeah.
This actually,
Does that mean that's
is
got
neon.
that in it?
That's red.
I want to touch it.
so,
Is it hot?
yes, it does get hot.
Can I touch it?
No.
That's
I
rude.
said Darth Vader.
What does the other one do? Is that one full of regular light?
I didn't even know my flash was actually on.
Now, how are you going to get the neon thing out of there if it's hot?
I'm letting it cool down. I love how y'all's questions are like the questions that don't really matter.
Mr. Hall, can we still get the light off? Because I can't really see your face and it's kind of creeping me out whenever you're talking and all I can see is
It's
black.
Darth Vader, bro. It's a heaven.
Can I touch it now? It's out of the vein.
See, that's it.
All right. Here's the one that was like really cool.
Green!
Actually
Is that one
did
gonna
a
be like
lab
blue?
on
Is
this
it gonna
one.
be like a bright blue or some junk?
It's not a big blue.
Oh, it has nothing.
It does not do crap.
I don't think it's
Hold on,
right.
fix it. I wanna see what color it is. What color is it? Ooh, still nothing.
There you go.
Oh,
Why is it more color?
that's just like kind of like.
Yeah, it's dumb.
Yeah, it's just boring.
That's not the one I thought it was.
Give us some color, man.
Yeah, we wanted to see some color.
Now what element's in that? Is it still neon?
Pretty close.
This.
I just don't know what element's in it, man.
The red one's like.
You're so right. Let me just put this away and I'll go back to the board.
No, it's okay.
No, girl. No, girl.
That's fine.
No, girl.
Honestly, this color is the best one.
You got any of them that's like green?
What does this have to do with the
Aw.
ground state?
Can you now show us sodium and potassium blowing up?
They got mixed up.
Hey, can I get a pound of potassium and throw it in a lake? What if I buy it?
I wouldn't recommend it.
Well, yeah, you told me about the one dude that threw potassium. It was either potassium or sodium in his creek.
Alright, so here's what I want you to do. I want you to explain to me what's happening.
Well, there's.
Why do I see the pretty colors?
The electrons on the neon elements get excited and it's
A little louder, John.
the electrons on the neon elements getting excited and emitting photons so we can see.
Exactly. Now, different ones had different things. So the one I just pulled out there that was orange, that was helium. This is typically the lady's favorite.
Alright.
Oh, it's purple!
That is.
That's
That is pink, Levi.
I'm colorblind, leave me alone.
So what is happening here?
It's
Pretty colors.
Explain the science.
Kyla, that was such a good explanation.
John already explained it for us.
So explain it to me again, because John was the only one that explained it, and that concerns me.
Can you
At this
tell me-
point, we should all be able to explain
Can
it.
you tell me what the
Especially
element
if I
is
was
inside of
here
it?
yesterday.
This is hydrogen.
Oh, that's cool.
Okay.
Wait.
So this is the conceptual part of this.
Yeah.
Is what I'm talking about. Welcome to science class, ladies and gentlemen. You've never had a science class like this before. You have now.
No.
You have to explain out and reason out the concepts. It's not just good enough like, hey, congratulations, you can do electron configurations. I'm so happy for that. That's awesome. I need you to be able to explain to me if something jumped from the 3s subshell and jumped into the 5s subshell, and then jumped back from the 5s subshell back to the 3s subshell, what happens?
Yes.
Yes.
Yeah. The Lord.
You see the light?
Light.
Yeah.
See the light?
Now it's in the ground state.
What am I doing?
Turning it on. Oh, lifting it. Turn it on. Oh, making
See
it
the light?
excited.
Yeah.
See the light?
Yeah, now it's in
No.
ground state.
Why?
Because
What
one's
is
in the
happening?
ground state and
You
the other
turned it
one's in the
off.
excited state.
You can't look and say it's in the ground state and then the excited state,
took
because what's
advantage.
happening is they are at simultaneously situations in here. They're going excited state to ground state, excited state to ground state, excited state to ground state.
Yeah, because you
Continually
turn
right
it on
now.
and off.
How we know that? Why is this taking place?
You gave
Because
us
it shows
energy.
us light.
I'm giving
Photon.
it energy
Yeah.
from the electricity
Yeah.
Yeah.
that's in the receptacle.
Yeah.
So the electricity travels
Yep.
into here,
Yep.
There's energy.
gives the energy in,
Mhm.
passes the electrical current through the tube, and then what happens is it passes through the tube, it gives energy to electrons, and electrons will do what?
Give off photons.
Give us photons so we can see light.
Hey, somebody's here.
Who's here?
I don't know, I can't see.
Somebody that knocked on the door, I guess.
There were two girls, I think. Or maybe one.
Interrupted class.
Do you want to come learn about photons and pretty pink lights?
Oh, there was two.
The D-holes.
Is it another D-Hall slip, dude?
Billy took every deal.
Yeah, that's
How do you keep getting more D-Hall slips every day?
for a test, and then we can't get her to get home.
Is it bad that some of
Oh, no,
the-
you should come here, yeah.
Yeah, but that's kind of awkward.
I said, is
What,
it bad
they're
that
sitting in
some
the
of
hall
the-
and you're getting help with chemistry? It's more torture than them.
They're gonna have to learn chemistry too.
Exactly. What happens, electricity comes in, it takes the electrons, adds energy to them, and the electrons go to the
Excited state?
excited state.
Yeah.
Does the electron stay there?
No.
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 The electron doesn't like staying there, it will go back to where?
They're ground
Ground
state.
state.
But in order for it to go to the ground state, it has to what?
Give
Over
off
that light.
Give off photons and release energy.
It has to give off energy, and it gives off energy in the form of photons. In this case, what are you seeing?
Photons. A pretty
Well,
light.
what color?
Pink.
That tells you everything, because guess what? That photon, all those photons are being released right now that you're seeing the pretty pink color. What do you remember back
The
to?
photons are girl.
Oh my gosh.
Oh my god,
You're gonna be like the
the
girls I had in
wavelength
class.
chart thing. Hold on, God give me a second, can't think of it.
Wait, what was the question?
The light spectrum thing.
Gold.
Yeah. Oh, it's so bright, Mr. Hall.
Electromagnetic spectrum, electromagnetic radiation, you're seeing a color, which means that color corresponds to what type of electromagnetic radiation.
I don't see pink up there.
Pink is a mixture of colors. It's visible light. The visible light that you're seeing, this is how this whole thing's going to correspond out to us. All of that is a summation of the different photons coming off. This is how you get different colors from things. We'll mix those colors together.
Can I touch it now?
With it, dude.
Next Friday.
Is it gonna explode after a while?
No.
That's rude.
Exactly.
This is what's taking place. But here's the cool part.
It explodes.
We use this premise and idea to determine things.
Yeah.
Perfect example.
It don't explode.
Sure. I gotta get a light on.
Nuh-uh. You already have one on. It's pretty pink.
Comes over at light. Watch your eyes.
Oh god.
I can't.
Now, who's baby?
Mine. Hence me and her in the picture together. I gotta just run off with random babies and take pictures.
Yeah.
That'd be creepy.
The way she was looking at you in that picture, that was funny. She was looking at you like she was done with you.
Who looking at you like shit?
There we go.
Yeah.
Perfect. Pull it up.
That's on that.
There you go, Mr. Hall.
No, you do. What? Just press on the website.
There we go. Here's what we're talking about.
But the other one has more.
So, why do we get pink?
Because there's a mixture of colors.
Because it's a mixture of red, blue, indigo, and violet.
I didn't know that was pink.
You're seeing every one of them. But here's the cool thing that takes place. If you run it through a prism, it actually breaks the light out like this and gives different bands to it.
Do you have a prism? Hey, check see if there's any good any DeVitos in that can.
Probably is. You're sassy.
Oh, Mr. Hall,
What?
you were the sassiest person I know.
No, I'm not.
Girl.
Mr. Hall,
I'm a boy, but thank you.
I see all a bunch of different colors. I see blue,
Dude, that's
green,
lit.
yellow, red.
Look,
He just said You not like being called girl?
I don't.
It's not his legs.
But you give off such teenage girl energy.
Teenage girl energy?
Yes.
When have I cried?
Teenage girls don't just cry.
We cry. We don't cry, actually.
Yeah, and did you
We
actually
actually
don't
can't
cry?
throw either.
I'm sorry if I hit your hand.
Oh, yeah, you're on.
Everybody else is talking a lot.
Oh,
Can you turn the light on?
Give that one back. It fell off.
Can you turn the light on?
I'm
Yeah,
going to,
we need
because we
to-
have to.
Right now,
Launch
just
that,
see
you
it.
can call.
Alright, here's the thing. So you got, so that everybody understands, you have the eyepiece side,
Yeah.
and you have the slit
Well,
side.
I hope you would.
What
look
you're
at
gonna
the
want is you can actually get up and come up. You're gonna want to put the slit side towards the hydrogen,
I
the
just,
eyepiece side of your eyes.
Wait.
I see a rainbow. I'm not even. Hey.
We don't want to see the rainbow. The rainbow is the white light.
Okay, but that was pretty cool though. I was
Pretty
a
lit, I ain't gonna
rainbow.
lie.
What about red?
You can get up and come closer, everybody.
I don't need to come close. This is
You
perfect.
got in front of it.
Oh, now I do have to come closer because they got
Ow,
my
that's
way.
my toe.
Oh my
John.
gosh, I can see the colors. I see purple and blue.
I'm so excited. Let me out of here. I'm being crowded.
Oh my gosh, I see
I say,
red.
Yeah, imagine how I
Boys that I
feel with these
see
two tall.
I see purple, a greenish blue, and a red. Oh, and I see pink. Oh wait, no, that's just pink light. You guys see this? Okay.
You may have to turn your
It's fine.
spectroscope just a little bit.
No, I was thinking you couldn't see, but I realized he was really
You got
tall.
so scared.
We're 10 feet tall. We can water them everywhere. This is actually kind of cool.
Yeah, it is.
We're not gonna say that.
Wait. That's all you think of things.
Y'all see the colors?
Hey, can you put another one in there so there's even more color?
There is, but this one is like the perfect one. So like even if you take physics and you take a physics 2 lab, you'll actually do a lab with this. Yeah, because what you can actually do is what we're going to get into. So you remember how I asked the question, how can we determine what is on a planet and we've never visited it? Have no samples or anything from the planet? How can I look at you and tell you, yeah, that thing's there?
Are we gonna look at the color of the planet and decide?
No, what you do, we collect the light coming from the planet, we run it through a prism, we break it apart, and whenever we break this thing apart, what we actually do with it is we analyze and we look at where the different points are on the visible light spectrum. Because remember, all of this corresponds to a certain wavelength. Since it all corresponds to a certain wavelength, that tells us that every one of these photons coming off has a certain amount of energy, which corresponds to the certain amount of wavelength. So what we can do is we can work backwards and determine the wavelength for these. And then here's the really cool part. Every one of us in this room, we have a certain wavelength, we have a certain fingerprint, right?
Yeah.
Every element on the periodic table has a certain fingerprint. There's hydrogen.
Ow!
There's helium.
You got issues with
There's oxygen.
Maybe it's about.
Every single one of them holds a certain wavelength
Flagpole.
of this. What you see with every one of these, so here's hydrogens, heliums, oxygens, these are called line emission spectrums. All you've done is we took the light coming just from this element, split it apart, and that's its fingerprint. So now what scientists can do, so if you want to know how scientists can look at you and tell you that this planet has this on it, this planet has this on it, this planet has this on it. The reason they can do this is they are actually breaking the light apart in prisms, and they are analyzing it and determining what elements are present. So if you want to know how a scientist can tell you that that planet is mostly hydrogen, here's why. How can they look at you and tell you that at the sun, the sun is mostly hydrogen and helium? Because of the line emission spectrums. Please put my spectroscopes back in the box.
Can I just like,
You
can I just like give you like 80 warnings and take you some home?
It doesn't kind of good after done it. I could have gone blind. I mean, maybe not blind.
Warning, I'm gonna go to the board.
Do I have to put it back?
I mean, unless you want to steal.
Nah.
So here's the thing, how can we determine what is on a planet we have never visited? The same thing applies to anything in the solar system. We take the light coming from the planet and break it apart through a prism.
Mr. Hall,
Give us what?
you don't have any shoes on?
Man, I knew I forgot something this morning.
How long have you been without shoes?
Huh?
How long have you been without shoes?
Whole time.
Whole time.
How come we just noticed that?
Because you're not looking at my feet, you're looking
Maybe we
at the
weren't.
board.
What?
That gets weird. Through a prism to give us
Excuse.
a line emission spectrum
I was just looking around and saw it.
That was so random.
of
I don't know where. Probably you.
Hold on.
light
Here.
coming from the planet. This gives us,
This is the longest answer I've ever seen.
there's a lot of explanation here, man. Big thing is, there's a lot more explanation in the explanation.
This gives us blank. Wow.
The fingerprint of elements present.
I'm glad they used periods.
Go back through
Yes, very proud.
and erase all.
So here's the thing, is this like, what is happening? You get the light, single the source of light out, we run it through a prism, we break it apart to get the line emission spectrum. What is a line emission spectrum? Line emission spectrum is just what you're seeing over here on the board. It's where we take apart, break the source of light apart. Once we break it apart like that, then what we'll get is the line emission spectrum, which is equivalent to the fingerprint of the element. Where is the light coming from that allows us to do this? Everybody's still writing the answer, and that's what you care about right now, isn't it?
The sun.
While you're writing this, let me explain this to you. This right here is what I'm talking about. This is a conceptual question. There's nothing to calculate here, but you have to be able to explain this to me. A good indication for you is how much time did I spend getting to this? I spent 2 days. You had to understand what we covered yesterday to be able to understand what we've covered today. And then you also know me very well by now, except for you, but you'll find out real fast. What does Mr. Hall like to do with everything?
Find some kind of trick.
Yes. Put some
Put it
snacks
together.
I like to connect it.
Be dramatic.
Hey, she
Like
said put
quiz.
it together.
I like to connect it. All of this is working off because here's what happens. Every one of those bands you're seeing corresponds to a certain wavelength of light. From that wavelength of light, you can calculate the amount of energy. Tomorrow in your lab, you're going to be looking at pretty colors. Gentlemen, you're going to get at burn sticks.
Yay, I love burning sticks.
Yeah, man.
Ladies and gentlemen. Okay, ladies, you get burn sticks. Ladies and gentlemen, you also get to calculate out how much energy are in those photons being released off.
And then you made it.
Hey, so you start. Let's start here. We had sticks.
You wanna be?
I remember.
I'm gonna call it stick. Okay.
Just try to make sure they put that first.
Sticks were soap. Different compounds.
Breathe, buddy.
Girl, basically what I said was that.
What's that compound solution?
Various substances, compound solutions, and I was
Yeah.
kinda close,
So the sticks were soaked in different compound solutions. The sticks were then placed to
David Adams to the office.
No, I'll be right back, I'm just grabbing money.
What did the fire do for us?
It changed colors.
Thanks so much. It did something besides change color. What does the fire do?
Gives off photons. Photons has to be in here somewhere, dude.
Energy, maybe a higher energy level.
Gives energy and makes it go to the excited state. So the sticks were placed into a flame that added energy sending electrons into an excited state. Then what happened?
Yes.
So electrons don't stay in excited states. The electrons return to the ground state. But can it just do this? Why can it not just do this?
Because it has to give off the energy somehow.
Has to give off energy. Why does it have to give off energy?
Because it ain't tired.
What's the difference with the energy levels?
15 joules.
15 joules. One's higher than the other one, so if I want to go from second energy level to the first energy level, what has to happen?
You gotta lose 15 joules. In photons, buddy.
You got to give off 15 joules of energy.
Just say that.
So the electrons return to the ground state by giving off energy.
Lachey Stinson to the office. Lachey Stinson to the office, please.
One, God's great answer, like one.
I think, Letterman. jackets.
You get the sock glove.
I don't know, there was a lid line.
I did.
Do it on lunch.
I did.
Why are they going all this?
No, I'm just needing two for now. Yes.
So, the electrons return to the ground state by giving off energy in the form of photons. So they give them off in the form of the photons. The photons have,
Piper Gibson, Zoe Goff to the office, please.
how many announcements is that already?
I have to make you mad.
61.
I got 6, remember.
I mean, yeah, basically.
The photons have a certain wavelength. That is a certain type of electromagnetic radiation.
Please be done.
Yeah, that's not gonna fit my picture.
I'm ready for that.
Nothing's an issue. How y'all like that?
It's so good to be back.
It's good.
It's like I never left.
Okay.
Are you done now, though? Okay.
We can be done.
Go, just go ahead.
We can be done there, but we won't write this part. But in our case in the lab on Friday, the photons correspond to visible light. So we saw the different colors. Now, here's what I want you to do. In your notes, write the question down. That's on your entry slip. Underneath it,
Right there.
write this. You want to know why?
Okay.
Look at me. That's the conceptual part, ladies and gentlemen. What happened in the lab on Friday? The sticks were soaked in different compound solutions. The sticks were then placed in a flame that added energy, sending electrons into excited states. The electrons came back to the ground state, but had to give off energy in order to do that. And that form of energy is the form of photons. And the photons have a certain wavelength. That is a certain type of electromagnetic radiation. Yes.
I was right on that, James. I just read it on the news.
Yes. There's a reason for this. Remember how Mr. Hall had the conversation with you guys off your last quiz? I love you all dearly, but you suck at the conceptual part. Welcome to science class. This is what you're missing. You guys do not have the ability to explain things yet. We have got to get you into this type of explanations. Looking and saying, what did you do in the lab? What happened in the lab on Friday? We burnt sticks. Well, no duh, Sherlock. Thanks for telling me. Now give me the science. Got me? I gotta whip you in shape. We got 4 days before Friday.
I got a question.
Yep.
On the word ground, how did you manage to make a U and an M look the exact same?
That's cool.
See, what I'm saying here?
Just
the
happens,
handwriting
man.
is insane. That is strong.
You got that question right down there?
Ready? Oh, yes. I'll take a picture. I have to wait till you're done, because you just keep
I'm
going.
done.
They've been on for like 5 years. but
Let's go. Let's write. I'm giving you valuable instructional time.
Mr. Hall, you know how we had that discussion one day? And you're like, so you self-diagnosed your astigmatism? Well, I went to the eye doctor. I actually have it now.
Now, here's an apology.
You should wear your glasses.
Well, they gotta be made at.
What?
I picked out my friends, but they gotta make the twins.
Your life will change forever. You'll be like, oh my gosh, this is what normal people see. Thought everything was just blurry.
It's water. I can read that back from my notes. I can tell what it is, but.
So why are you making fun of me if you can read it? Make fun of the words you can't read.
Because it's really hard. It's really hard to do in this class.
That looks
The
like
handwriting
word to
is
me.
so.
You know it's word. Don't talk about it.
Handwriting is
The W looks like a three.
Hey, you can talk trash about my handwriting, and you can explain things.
I'm just hoping.
Till then, it ain't accepted.
It's better. That's not what it was, leave, and I was like, there's no way. You wrote leave. Oh,
Kids.
To be fair, I understand where they're coming from. You managed to make a U
Everyone
and
that's
then
ever
make
took
a
this
That's dear Mr. Quarterback. Nobody asked.
Then he gets all
Congrats on the win.
sassy about it.
Thanks, man.
All the business.
Sorry I couldn't be there.
Huh?
Sorry I couldn't be there.
I noticed you weren't announcing.
I told you I couldn't be there.
I didn't remember you telling me.
Really let him down.
Sorry. Listen,
It's okay.
I'm sure whoever they had did fine.
We had Lennon Stable.
Lennon announced?
It's
And
bad.
they're calling out half the game.
The second half was bad.
So Lennon announced the game?
Tried to.
There's no way.
Did you try being me?
Nobody can.
Yeah, but it was a very terrible impersonation.
And then Friday, they got a lab
But is that more
on my deathbed,
important than chemistry?
begging for mercy.
I'll have to see your life. Alright, so this is the explanation part. This right here is the conceptual part. What happened? You understand, ground and excited states, energy transfer. Energy can't be created or destroyed. You've got to understand these parts and you have to be able to explain them. Then, there is the calculation part. So I asked you, for those, I want you to calculate the energy of those photons. Well, how in the world are we going to calculate the energy of those photons? We have to be able to do it based off of the electromagnetic spectrum. On the electromagnetic spectrum, we have the visible light spectrum. Visible light, if you look at it, bada bing, bada boom, we're sitting somewhere around 500 nanometers with copper. I'm going to use copper for example. So copper is green, you got green flame from it, you're sitting somewhere around 500 nanometers. You can be off a little bit, also caught up on that, but we're at 500 nanometers. So I'm trying to find energy, and here's how we got to do it. If you look at your two equations, speed of light equals wavelength times frequency, and energy is equal to Planck's constant times frequency. Better.
So, 5 looks like.
So I'm ultimately trying to find energy, but wavelength is not here in the energy equation, so I have to find frequency first, so I gotta find frequency from the speed of light equation. So frequency is equal to the speed of light divided by the wavelength. Issue we got, you look at speed of light is 2.98 times 10 to the 8 meters per second. Issue, we are in meters. So we have got to convert that thing out of meters, right?
For sure.
Yeah. I don't remember if I gave you one of those or not.
Is that an S or a 5 up there? It's probably
Is it with units or with numbers?
numbers, but with you, I can never tell.
You talking the
That's
meters
with
per
units,
second?
Up there. I think that's up there. No, up there.
One of these days, he's just
That's
gonna give
fine.
up and put
That's
real on.
Okay, it looks like an
One of
S.
these days, he's gonna give up and just put real on.
I can't,
Well,
if I don't want to get it wrong, it looks like a 5 and an
Good dog.
500 nanometers.
S. Thank you.
It's like me saying the wavelength equals 500 nanometers. Try to keep up.
I was trying to read the handwriting and like also listen to what you're doing.
I was gonna compliment you and say that your SAS level was at like an all-time level low today, and I was really excited about it. It only took about 10 minutes for you to wake up, and the SAS just started coming up, crashing.
I mean,
Anyway, we can't do this in nanometers, we gotta be in meters. So, we gotta convert it.
500 times 10 to the negative.
So 500 times 10 to the negative 9th meters. Way I get that, remember how we do the metric conversion? We look at nano, nano is negative 9, minus the base unit, which is 0, which equals negative 9. So now we do that in the calculator. All right, so we have 5.96 times 10 to the 14th hertz. Isaiah, do me a favor, walk back there, open that door, and I'll watch it. So 5.96 times 10 to the 14th hertz, that's frequency, not energy. Now we can solve for the energy. So we get to the energy. Energy equals Planck's constant times frequency. Planck's constant is 6.626 times 10 to the negative 34 joule seconds. Multiply that by the frequency we just solved for, 5.96 times 10 to the 14th hertz. Hertz and seconds cancel, leaves me with joules. Thanks, Jose. So we get 3.9491 times 10, negative 19 joules. And that's the energy for the copper chloride we solved for. Hey, Kyle. This is a 3. That's a decimal. That's a 9,
I'm a little unsure
4,
about
a
that.
9, and that's a 1. Make sure you know that's a 1.
What about that beside the J?
Right there,
No.
That's an S.
that's a negative 19.
No.
If you put that in a calculator, you'll see it.
Up. You keep going lower. Yeah, it's that. Is it like an and sign or is it an A?
That's S for seconds. That canceled
Mark it
out
out.
because of hertz.
Oh.
You should be able to do this. I shouldn't have to walk you through it.
Okay. Nobody else wants to say anything. I'm just. She didn't know. What was it? Something up there was.
Throw her under the bus, she didn't say anything.
Yeah, well, this person right here, they were clueless, okay? I'm not asking for
Hey, you done writing that yet? I'm ready to move on.
We're over here, yeah. She don't put anything on it. You
Kill
spoke to me. What?
Ridiculous.
Even I got that finish right. I don't take that to me.
Yeah.
All right, here's the thing, okay? Here's what I gotta get you to understand. This is a science class. Science does a beautiful thing. You have to understand the concept. This is the conceptual part of what you did Friday. Then you have to understand all the calculations. That's why people want that. Way to go.
I didn't mean
Don't yell at
to. It was an
her.
accident.
Yeah, I don't even mean to her, dude. It was an accident.
I'm gonna report you for
Oh my god, the TV broke.
You know who I am.
Got a red line going through it.
Did you say that sass?
She just said who is that? It's kind of sad.
Who am I? Yeah, you give me loves. Oh, I love you. Give me a kiss.
Who is that?
Mwah. I love you. You say hi to everybody.
County gamer.
Say hi.
I am not. I'm just saying, chemistry, your daughter is
We'll go
probably.
play.
You gotta tell your mama. Hey, you have a great day. Love you. Hey, Hannah. You look cute.
It's like, oh,
Alright,
bring Hannah back in here.
Just-
Let her teach the class. They learn a lot. That poor kid.
You learn a lot.
That's-
so you gotta understand the conceptual part, and you have to be able to understand the mathematical application part. You got me?
Mhm.
That's what makes this class so difficult. You have to be able to do both. Questions?
How, on the list of the things you love the most, okay, your daughter, what's winning there?
Hannah, she wins.
But barely.
Question. Yeah. It's
Nah, Hannah wins by a mile. That's not close.
well, chemistry was far behind.
Yeah, like, there's Jesus, Mary, Hannah.
Chemistry.
No, y'all come before chemistry.
Oh my God.
No, they don't. No, everybody.
He's lying.
If you're bleeding out the mouth, you show up for chemistry.
If you can breathe, I don't get why you're not here.
I couldn't breathe. I had to go to sleep with
I'm
one
gonna be in my
mask on.
deathbed about to pull the plug and Mr. Hall's gonna be like, why aren't you in chemistry?
Alright,
You're missing quiz day, bro.
Get a call in the hospital.
so,
And then when you finally walk into his class, he just gives you that really disappointed look, and then doesn't say anything. That's like the worst feeling ever.
Or just
Yeah.
looks at you and goes, I'm not mad. Just very disappointed.
He'll just look at you, he'll go,
We have a test.
I was more.
that's it, that's all you get.
I was more disappointed when he did that. And my mom said she was disappointed in me.
I know, it's sad, it's very sad.
alright, so there is something we've talked about, but we haven't really talked about it. So I want to go back and cover it before we get into like the really cool stuff. So we're going to focus on.
So you want to do something else that's new before we do something cool?
Yeah.
Makes sense.
I don't want to hear it. You all laugh yesterday, right? You're living good. Well, not yesterday.
Nobody got laid yesterday.
Friday.
Yeah, Friday is. Alright, so focusing on electromagnetic radiation. So if you remember back whenever we did those calculations and you worked through problems, you determined certain things, I would ask you questions like, is it harmful? How do we determine if something is harmful or not?
I don't know. Pass.
Here's the way to look at it. If
UV rays on.
it can cause / lead to death,
No dirt.
it is harmful.
I mean, I'd say.
Who would have thunk it?
I know, right?
Is that all you're gonna put for that?
No, I'm gonna put some more down here.
Okay.
Thank God you know what the elementary kids, they're sassy, man.
Okay, you just don't go in there and go. I don't want to hear it.
Girl, I give it back to you.
You have words
Hey, first things first.
You definitely get
You
the
look
food.
absolutely beautiful today. Gorgeous. I'm a blessed man to be married to you. Second off, I cannot wait to see you later. Love you, gorgeous.
It's just like
I love you.
every day. You should go do it's like your.
All right, so the
Is your goal to like weird us out?
why is that weird to you?
Like it was just weird to hear.
It's like I'm hearing it from my parents. It's just like, girl, why are you saying that right now? It's supposed to be chemistry.
Yeah, we're locked in
That
on
was
this
chemistry.
Oh,
Okay.
We're locked in.
It's just kind of like hearing my mom and dad talk.
Corporate.
All right, so
In the car. You gotta get down here. Don't stop writing more.
listen, y'all talk about me. I've heard the way y'all talk to like the opposite sex. Talk about
It's different, bro. You act like a dad to us. Nobody wants to hear their dad talk to their mother like that.
Exactly, it feels like
I've heard.
mom and
I'll be
dad.
sure to let Mary know later on. It's like, hey, just so you know, first period camp looks at me like a dad, you like a mom.
Honestly, yeah, it's weird every time. It's just like, guys, come on.
Well, it is. If we don't have you in class, we have her every morning.
I love her.
And then what's she do? Like you could be like,
She's so sweet.
he'd be disappointed in you.
Oh, she don't talk. She just does the same look. She just goes. Look like it's awful. It's terrible.
It's because it's first period. It's early in the morning. She's not a morning person. Whenever we first got married, it was a treat. I'd wake up, ready to go. She'd wake up. Alright, not harmful. So you look at the forms of electromagnetic radiation, ones that are not harmful. We have radio.
I feel like when Mr. Hall wakes up, he starts patting himself looking for his periodic table. Where to put it? What pocket?
Microwave.
What'd you dream about? Mole conversion.
Infrared. I'll give you everything out. That's pretty good. So infrared.
He's gonna have, in his will, there's periodic tables being given away to someone. He has like a collector. You have a collector's edition periodic table somewhere. Nice.
He has the first periodic.
Hannah's gonna get his biggest periodic.
You know those really nice like 80s photos? Like portraits?
Alright, so non-harmful. Radio waves, microwaves, infrared, visible light. We're going to go through these of what each one is useful for, but I want to hit the harmful ones and not harmful ones first. Then, we have harmful.
I don't know. If I got stuck in a microwave, it'd probably kill me.
Yeah, I can think of ways that microwave can lead to death.
Okay?
So is
When have you
radio.
ever seen a microwave big enough for you to fit in it?
Okay.
I've seen a microwave big.
Like if I jump into my tub with the radio that's turned on, I feel like it could.
I can't fit inside a microwave, but smaller peoples can.
Okay, that's not radio. We're talking electromagnetic radiation, radio waves, not the physical radio. And that's not the radio that would do the damage. That's the electricity traveling through the water and the ions in your body, letting the electricity travel through.
I can't.
Actually.
So UV rays?
Microwaves are just dangerous.
But it's a little hard.
No, it's not the literal microwave.
X-ray?
It's the microwaves, bro.
Gamma
What is a UU ray?
ray. UV ray.
I'm not laughing because the handwriting's bad. I just had something stuck in my throat.
Yeah.
Okay, see, I'm not the only one.
Here's the thing.
Anything with ray.
How can UV rays be dangerous and harmful to us? Ladies,
Skin cancer.
prom season's around the corner. Gotta hit that tanning bed.
I think I'm good. I've already got my tan over the summer, and I think I'm good.
So UV rays can lead to skin cancer.
You might.
That's why everybody looks and says tanning beds are bad.
Mine was fine. Mine was great. Comfortable.
It's got a little extra protein in there to help.
Yeah.
But you got x-rays. We use x-rays for it.
Check if you got broken bones.
Check bones. Okay? So this will travel all the way through the system. So x-rays can lead
Is
to
he good? He's not.
cancer.
Water, buddy.
Mr. Hall's just
Hey, it helps if you cough it up, spit it out.
I I went through that a couple weeks ago.
So,
Bottles are not pretty.
alright, gamma rays. We look at gamma rays. And why are they harmful? Gamma rays.
Probably also
Gamma.
cancer.
Somebody would tell us that'd be.
Guys, we were right.
Wow.
Let me guess.
Cancer.
Cancer.
Mine.
So-
Cancer in people that.
I'm getting a sense from this lesson that we're learning that cancer is not a good thing.
It's correct. You should know that from last year when we talked about it.
We talked about cancer.
You should know that from life.
Oh man, I don't know. I don't
Yo.
know nothing about biology.
Mutated uncontrolled growth of cells. Don't stop growing, causes tumors.
I did take notes in biology.
Yeah, I know you did. So these are the ones that are not harmful. These are the ones that are harmful. Tomorrow when you come in here, we're going to go through these and talk about what they can be used for. In other words, what is Mr. Hall saying to you? Mr. Hall is telling you tomorrow is a conceptual day where we talk concepts.